Hi guys, today we're going to be looking at the volume of solids. We're going to talk about finding the volume, finding something else other than the volume if we're given the volume, and then also about composite shapes and something called Cavaliers Principle. So we'll start with finding volume. First off, volume is just the amount of space to fill an object such that it's solid. So you can think of like a swimming pool. The volume of the swimming pool would be talking about the amount of water that can fit inside that swimming pool. So in order to find volume, there's three really specific steps. The first step is to look at the reference sheet and write down the formula that you need. The second step is to plug in the given information, such as the height or the radius or whatever it happens to be. Then we're going to use the calculator to determine our answer. Now, if we're talking about the reference sheet, there are a few formulas not on the reference sheet that you need to memorize. That would be these four right here. Big B is used in the reference sheet several times, and it stands for the area of the base. It's not really a formula that you have to memorize, but it is something that you have to recognize. Big B means the area of the base. So, for example, in this example over here to the right, it says find the volume of a regular pyramid where the base is a square. So to calculate big B here, we would take that edge of 6, multiply it by 6 to get big B, because area of a square is length times width. We're going to see more examples of this when we get to the next part of our notes. When you're using the calculator to determine your answer, there are two different ways to write your answer. One of them is in terms of pi. So you'll see in example 2, it said, first leave your answer in terms of pi. This means to type everything in the calculator except for the pi, and then write down your answer and attach a pi to your answer. The second option is to round to the nearest whatever, nearest cubic foot, nearest tenth of a cubic foot, whatever it happens to be. So that means type everything in your calculator and just round. Now, sometimes we do have to work backwards. When they give us the volume, we have to find a length of, say, the radius or the height or the length of the side of a base of a rectangular pyramid, something of that sort. So again, still look at the reference sheet, still plug in the given information, and then use your calculator to determine the answer. Now, something that I want to point out here is that if the volume is given in terms of pi, you must write it just the way that it's given. So for example, in this little example off to the side, it tells us that the volume is 60 pi. So you can see that when I was plugging in for the volume, the V, I kept it as 60 pi. That pi is important to you. And then when dividing, which you often have to do when solving for a height or a radius or whatever it may be, use a big set of parentheses like you see over here in this example. I was dividing the right side, the 1/3 pi r squared times 5, I was dividing it by a big pair of parentheses to get rid of the 1/3, the pi, and the 5. Using those big pairs of parentheses helps you to do the order of operations correctly in your calculator. Whatever you do to one side, you must do to the other, so I have to repeat that division with big parentheses of 1/3, pi, and 5. You definitely have to have parentheses when you divide by pi. If you don't, it ends up multiplying by pi, which is not so cool because it changes the answer. The next part we have are composite shapes. That's just one or two or more, not one or more, two or more shapes attached to each other or stacked within each other or something of that sort. If the two shapes are stacked on top of or next to each other, then we have to add the volumes. If the shapes are set within one another, then we subtract the volumes. And we'll see examples of this in a few minutes. Now there's also something else called Cavaliers Principle. This has yet to come up on an exam, but it's been on sample questions released by the state, and so we just want to make sure that we make mention of this. It says if the area of the bases and each cross-section is equal, that's step 1. The area of the bases and cross-sections are equal. And the heights are equal, that's step 2. Then the volumes must be, this got cut off, it says must be equal. If yours is cut off on your paper, please fix it. Make it say must be equal. That is step 3. So there's 3 parts to Cavaliers' Principle. Area of the bases, the heights, and the volumes. When we talk about the area of the bases, we can also talk about the cross sections. So if we look at these stacks of quarters, we know that each quarter has the same base area, and each cross section, each chunk of it is the same as all the others, so they're equal area of bases. They also have the same height, h. If you count the number of quarters in each stack, they're equal. And therefore, when we calculate volumes, they end up being equal. And again, we'll see another example of this in just a few minutes. Go ahead and flip your paper when you're ready to start practicing with me. This next page is just your reference sheet. Today we're going to focus only on a couple of things here, such as these volume formulas, starting at general prism, going all the way down to pyramid. There are other formulas on here that you may use at one point in your life or another, but for now we're going to focus on these main 1, 2, 3, 4, 5 formulas, in addition to some of the ones that I said you needed to memorize. Rectangular, prism, cube, and hemisphere. So we'll start this first problem that says a fish tank with a rectangular base has a volume of 3,360. So let's just attempt to sketch this off to the side. It is a fish tank with a rectangular base. So start by drawing a rectangle. Draw another rectangle that's the same exact size, diagonal and towards the right from it. Then just connect your vertices. Top left corner, top right corner, top right corner, so on and so forth, until you get that tissue box looking shape. So they tell us that the volume is equal to 3,360. They tell us the length is equal to 14 and the width is equal to 12. Our goal is to find the height. So I'm going to label this picture, length is 14, width is 12, and we're looking for the height. If you look at your reference sheet, you will not find a formula for a rectangular prism. However, you will find a general prism formula that says volume equals big B times H, where remember big B is the area of the base. So if you think about the base of this shape, it tells you in the question that it's a rectangle. So area of a rectangle, remember, is length times width, and now we still have the height attached. So now we're going to plug in what we know. They tell us volume is 3,360, so we're going to start with that. 3,360 equals our length was 14, our width was 12, and we don't know the h, so we'll leave it as h. So now we're going to type in our calculator 14 times 12, which gives us 168. So we have 3,360 equals 168 times h. Remember, our goal is to get the h by itself. So we have to divide both sides by 168. On the right side, they cancel. On the left side, that's what we're going to type in the calculator. 3,360 divided by 168. And we find that the height is equal to 20. If at any point in this video you want to do the calculation in your calculator by yourself, which I strongly suggest that you do, just pause the video when I tell you to type in your calculator, type it in, pause the video while you're doing it, and then hit play once you get your answer to check it with mine. As I said, I strongly suggest that you type stuff in on your own calculator so that you can get the practice. Of course, you'll have some practice in a few minutes once you're done with the notes section. However, the more you practice typing in your calculator, the better off you're going to be, because sometimes it is a little bit tricky to figure out when do I do a times, when do I do divided, when do I use parentheses, when do I not use parentheses. So again, pause when I say type it in your calculator, type it in yourself, hit play when you're done to see if you get the same value as I do. Okay, number 2 says which expression represents the volume in cubic centimeters of the cylinder represented by the diagram below. Now I want you to take notice of these answer choices. All of them have a pi attached, so we're going to get our answer in terms of pi. So let's look at our formula sheet. You guys can flip backwards to find the reference sheet. We have volume of a cylinder is equal to pi r squared h. So now we need the radius, but unfortunately they give us this diameter of 12. Diameter, remember, goes all the way across. Radius just goes halfway across. So to get the radius, we divide by 2. R equals 6 then. And our height is 27. So we have pi times 6 close parentheses squared, and then times parentheses 27. Now remember, it says that, or we found that we're going to leave our answer in terms of pi. So the only thing that you're typing in the calculator right now is 6 squared times 27. Again, you're typing in 6 squared times 27. That gives us 972. But remember that we still have a pi, which needs to get attached to our answer here. So our final answer should be 972 pi. Example 3 gives us a cylinder again, where they tell us that the volume is equal to 4,000 pi. You can ignore the units essentially. We're never going to write our answer with units, and that might freak some of you out. It might even freak some teachers out, but the Regents exam in New York State does not require you to write the units, because if you write the wrong units, we have to take off points. If you choose to write no units, you're fine. So myself and other geometry teachers in our school strongly recommend that you don't write units, just so you don't lose any credit. Okay, so volume is 4,000 pi, the height is 8, and our goal is to find the radius. So r is unknown, to the nearest tenth. So we're going to find our formula again. It's actually the same one that we just used. Volume equals pi r squared times h. Remember that you have to write exactly what they give you for the volume. So this was 4,000 pi. Just because there's a pi on the left does not mean you get to get rid of it on the right. You still keep the pi. We don't know r, so we leave it as r, and then times our height of 8. Now our goal is to get this r squared by itself, which means we have to get rid of pi and we have to get rid of 8. Currently, both of them are being multiplied by radius squared. So to undo multiplication, we use division. And remember when I said that we're doing division with more than one thing, especially a pi, it needs to go in parentheses. Now you can think about this in one of two ways. Both of them cancel out the 8s and the pi's on the right-hand side. The first way you could do this is to type this entire thing into your calculator. 4,000 pi divided by parentheses 8 pi. If you need to pause the video to type that in, now might be a good time to do so. The second way you can think about it is, well, I have pi divided by pi, right? You see this? Pi divided by pi. If you divide things by itself, they cancel. So pi's gone, pi's gone. So the only thing you should type in your calculator, or could type in your calculator, is 4,000 divided by 8, which gives us 500, equal to r squared. Now remember, our goal is to just get r, so we have to undo squaring by taking the square root of both sides. Type in your calculator square root of 500. And we get 22.3607. It does say to round to the nearest tenth, so take that 3, look to the right. The 6 is above a 5, which tells us to round up. So the radius here is 22.4. Example 4 is one of those composite shapes. It says that we have a section of concrete pipe that's 3 feet long. This is also representing the height. H equals 3. It has an inside diameter of 4 and an outside diameter of 5 feet. What is the volume of the concrete in this section of pipe to the nearest cubic foot? So essentially we have one cylinder, then we have another one inside of it, and our goal is to figure out the volume of the pipe itself, meaning that red shaded part. Of course, this pipe goes backwards, so we need to find the whole volume, not just the circle. But I hope I can erase that. Nope, I can't. Okay, just ignore that pretty picture. They give us these diameters, though, and remember from the formula that we've used twice now for cylinders, we don't need diameters, we need radii. So what we do is just, again, cut it in half, divide by 2. 4 divided by 2 gives us a radius of 2, and 5 divided by 2 gives us a radius of 2.5. So our first goal here is to find the volume of the large cylinder. Our second goal is to find the volume of the small cylinder. Or you could think of this as the outside or versus inside cylinders, that's fine too. And then the third step is to find the actual volume. If there's a hole in this shape, that means one cylinder is set inside of the other, creating a hole, which means that we need to subtract. So we're going to go volume of the large minus volume of the small. Remember that for cylinders, the volume formula is pi r squared h. This is, again, something that you can find right there on your reference sheet. So we're just going to start plugging in what they give us. Pi, the radius we found for the large one was 2.5 parentheses squared, and then the height of the cylinder is 3. I want you to type this entire thing into your calculator. Pi times 2.5 squared times 3. And we end up getting 58.9049 for the volume of the large. We're going to do something similar for the volume of the small. We have pi times the radius of the small is 2 squared times the height of the small, which is 3. Again, type the whole thing in your calculator, including the pi. This time we get 37.6991. Remember that our last step is to find the actual volume of the entire pipe, so we take the volume of the large, 58.9049, and subtract 37.6991. Go ahead and type that in your calculator, please. I got 21.2053, and it does say rounded to the nearest cubic foot, meaning a whole number. So look to the left of the decimal at the 1, look to the right to see if we round up or keep. Because it's a 2 on the right, we keep it at 21. So final answer, the volume of this pipe is 21 cubic feet. Again, don't write your units. It already has it stated in the question, so you're good to go. Flip it over once you're ready. Alright, this next example says explain why the volume of the stack of CDs on the left, stack A, is equal to the volume of the stack of CDs on the right, stack B, using Cavaliers Principle. There are 17 CDs in each stack. So think about this for a second. We have CDs, of course they're in cases here, but each case is that little rectangular prism that you guys see there. And so we know that each area of the base here, if I were to take out that bottom CD, the areas of those bases are equal. And same with any cross section. If I were to pull out any CD case within here, each of them would still have the same area. So we'll start by talking about that. We're going to say the area of the bases and cross sections for each stack are equal. And then we're going to talk about the heights, because remember each one has 17 CDs. Just because they're slanted doesn't matter, they still have 17 CDs. So we'll say the heights of the stacks are equal. Also. Then our last sentence will talk about why the volumes must be equal. Therefore, the volumes must be equal. Remember, this was a three-step thing. The area of the bases and cross-sections are equal. The heights are equal. Therefore, the volumes are equal. Example 6 gives us a rectangular prism with a base that has a length of 15, a width of 4, and a height of 10. So let's try to sketch this. Remember when we did this the last time on example 1 or together, you draw two rectangles and you connect. A length of 15, a width of 4, and a height of 10. They tell us that we have a second prism with a square base that has a side of 5. So start by drawing, a tall rectangle this time. It doesn't really matter, as long as you have that square base going on at the top and the bottom. Side of 5. Now this base down here that I'm making really dark is square. So that means that the other side must be 5. They didn't tell us the height though, and that's actually our goal here. It says, what is the height of the second prism? So we're going to choose to call this h. They do tell us an important piece of information about the volumes, and it's that the volumes of the two prisms are equal. So our first step is to find the volume of the rectangular prism. Notice that I just wrote little v sub r. R for rectangular prism. You can call it whatever you want. You can say v sub 1, like v1. You could call it, VRP, rectangular prism. I don't care what you call it. You get to call it whatever you want. As long as it makes sense to you, you're good. So we're going to find the volume of the rectangular prism. We're going to find the volume of the square prism. That's a little s there. Sorry, that's messy. S. Square prism. And then third step, it says that the volumes are equal. So we're going to set volume of the rectangular prism equal to the volume of the square prism. When we think about rectangular prisms, again, this was not a formula on our reference sheet, but you guys have been doing this for years. Length times width times height. Length times width times height. So just plug in. We have 15 times 4 times 10. Type that in your calculator, and you get 600. Volume of the rectangular prism is 600 cubic feet, or whatever the units are. Cubic units, I don't know. Volume of the square prism, same type of thing, 5 times h. Don't be scared by that h. We have 5 times 5, which gives us 25. H still attached. So we have the volume of the rectangular prism, the volume of the square prism, and now third step is to set them equal. 600 equals 25 times h. Divide by 25. So then h equals 24. In this next example, we have a different shape finally. We have a cone. Let's try to sketch this cone. Start with like an oval base. It's really a circular base, but of course we're sketching here, so it's got to be oval to make this work for our picture. Taking a 3D object and making it 2D by drawing it. It says that it has a volume of 60 pi and a height of 5. The height goes from the vertex, this point at the top, straight down and perpendicular to the base. So this height is 5, and we're looking for the radius r. If you look at your reference sheet, you'll find a formula for the volume of a cone. That formula is 1/3 pi r squared h. So they give us the volume of 60 pi. We keep the 1/3, we keep the pi, we keep the r squared, but we replace the h with a 5. Now again, our goal here is to find r squared, similar to that problem about the cylinder where we had to find the radius. So to do that, we're going to use big parentheses for some division here. Divide by 1/3, divide by pi, and divide by 5. Divide by 1/3, divide by pi, and divide by 5. You have to do that to both sides, remember. 5's cancel, pi's cancel, 1/3's cancel. On the left side, pi's cancel. So now you're typing in your calculator 60 divided by 1/3 parentheses times 5. That's what you're typing in your calculator. So this ends up giving us 36 equals r squared. Remember to square root both sides to get the radius by itself, which gives us a value of 6. Flip it when you got it. We got a couple more questions to do together. I know these notes are long, but you're pushing through. There's a lot of different shapes, so I wanted to make sure that we talked about them together. All right, example 8 says the volume in cubic centimeters of a sphere whose diameter is 6 centimeters is blank. So our goal is to find the volume. They give us a sphere, and the diameter is 6. However, if we look at our reference sheet, volume of a sphere says 4/3 pi radius r to the 3rd power. Notice it's to the 3rd. Every formula we've used so far has put it to the 2nd. This is to the 3rd because we're talking about volume. And it's our one and only dimension to the 3rd power. So diameter 6, which means that all the way across this sphere, we have a length of 6. So halfway across for the radius must be 3. Remember, just cut the diameter in half. So now we have 4/3 pi times 3 to the 3rd. Take a look at those multiple choice answers. They are in terms of pi, which means type in 4/3 and type in 3 to the 3rd, multiplied by each other. 4/3 times 3 to the 3rd. And you end up with 36. But don't forget, bring down your pi. So our answer is choice 2, 36 pi. 2 more questions together and then you're on your own. I know it's annoying, frustrating to be listening to me for so long, but you're doing a great job so far. Example 9 says a soccer ball is packaged in a cube-shaped box with the dimensions below. Our goal is to determine the volume of the space in the package that is not occupied by the ball. So essentially what they're saying is that this ball goes from one side to the other in this box, but there's a little bit of space in here that's not occupied by the ball. And our goal is to find that volume of that space that's not taken up by the ball. So that means we have to find a couple of volumes here. First, we're going to find the volume of the cube. Then, we're going to find the volume of the sphere, the ball. And then after that, because the ball is set inside of this cube, we're going to subtract volume of the cube minus volume of the sphere. And of course, round to the nearest hundredth. All right, so volume of a cube is something that we haven't talked about yet. Remember that cubes have 3 equal sides. In this particular one, the box has a side of 20, 20, and 20. So to find the volume, you can do one of 2 things. You can take 20, multiply it by 20, and multiply by 20, which is really the same as 20 to the 3rd. That was your second option. So type that in your calculator, 20 to the 3rd, and you get the volume of the cube is 8,000. Now remember, this is not our final answer. We still have to find the volume of the sphere. So if we look at our reference sheet, we have 4/3 pi r to the 3rd. The radius of this sphere is already actually drawn in there for you of 10. So we have 4/3 pi times 10 to the 3rd. Type the whole thing into your calculator, 4/3 times pi times 10 to the 3rd. And you get 4,188.79. This is the volume of the sphere, so now our third step, I'm just going to carry it down here so I have room, is to take 8,000 and subtract 4,188.79. And when we do that in our calculator, we get 3,811.21. Because it says round to the nearest hundredth, we're actually already there. The TI Inspires do some rounding a little bit early. Sometimes they float like 7 decimals, other times they don't float as many, meaning they don't give you as many. So this one happened to be rounded for us. All right, last example together. It says that a right circular cone has a diameter of 18 inches. So D equals 18. And a height of 11. H equals 11. What is the volume of the cone to the nearest cubic inch? So we're looking for the volume. Let's take a look at our reference sheet. Volume equals 1/3 pi r squared h. Nowhere in here do I see anything about diameter. So take your diameter, cut it in half to find the radius. Radius is 9. So we have 1/3 pi times 9 squared times the height of 11. It says that we're rounding here, so we're going to type the entire thing into the calculator. 1/3 times pi times 9 squared times 11. We get 933.053. But it does say to round to the nearest cubic inch, meaning a whole number. So chop off that decimal, decide whether you're supposed to keep it at 33 or round up to 34. Because I have a 0 right to the right, that means we keep it at 933. Now there is something that I do want to touch base with you on the next page, because I guess I didn't put an example in here for us to talk about together. So flip it over one more page. I'm just going to keep you for another minute, and then I'll let you go practice on your own. So here we see our practice, and I want you to look down at the bottom of your paper at this composite shape in number 4. It says it's made of a hemisphere and a cylinder. Now we talked a bunch about cylinders, true, but we didn't talk about hemispheres. So let's quickly talk about the formula that you would use to find the volume of this hemisphere. Think about the word hemi-sphere. You have a formula for the volume of a sphere on your paper. 4/3 pi r to the third. But it's a hemisphere, meaning half of a sphere, so we have to divide our formula by 2. You still plug in the radius just the same as you would for a regular sphere, but your final answer for the volume of the hemisphere must be put over 2, or cut in half, divided by 2. All right, the rest of it you should be okay with. Remember, feel free to go back, rewind, pause, do what you need to do to help yourself be successful. Ask teachers questions that are there near you to help you out. Good luck, and get ready for your assessment.